Okay, welcome to day 7 of Mrs. Cucci's College Now Pre-Calculus class. We are on file R.6, Rational Expressions. By the end of this lesson, you will be able to determine the domain of a rational expression, simplify rational expressions, multiply, divide, add, and subtract rational expressions, and simplify complex rational expressions. All right. A rational expression is the quotient of two polynomials, for example, 3/5, or 2 divided by x minus 3, or x squared minus 4 divided by x squared minus 4x minus 5. They are all rational expressions. The domain of a rational expression. The domain of an algebraic expression is the set of real numbers for which the expression is defined. So since division by 0 is not defined, you can't have it, right? We get an undefined. Any number that makes the denominator 0 is not going to be a part of the domain of the rational expression. So let's find the domain of 2 divided by x minus 3. So again, it's all real numbers except for the number that's going to make the expression undefined. So what we can do is we can take the denominator and say, okay, when is x minus 3 equal to 0? Well, it's equal to 0 when x equals 3. So that means my domain is all real numbers such that x does not equal 3. And there's my domain. And now you guys should be used to this notation. We used this notation last year. Okay, the domain equals all real numbers such that x does not equal 3. Okay, so how do we find the domain of a rational expression? We take the denominator, we set it equal to 0, and we solve for the value of x. That's what gets excluded from our set of real numbers. Okay, so let's do another one. X squared minus 4x minus 5. So we're going to take that, and we're going to set it equal to 0. And we know how to solve quadratic equations, right? We factor minus 5 plus 1. Don't forget that equals 0. It needs to be there every single time. We're not going back and forth from equation to expression. It has to be there. Zero product rule. Okay. So x is 5 and x is negative 1. So again, our domain is all real numbers such that x does not equal 5 and negative 1. Okay, so domain should be pretty simple to find. Does it get more complicated? Yes, we're going to stick with these ones for now. All right, so simplifying, multiplying, and dividing rational expressions. So to simplify, we're using our knowledge that a times c over b times c is the same thing as a divided by b times c divided by c. We know c divided by c is 1, which means that they can simplify to be 1, and we're just left with a over b. So we're going to use our knowledge of that to simplify these rational expressions. 9x squared plus 6x minus 3 divided by 12x squared minus 12. So we're going to start by looking at what we have, and we're going to factor. Okay? So let's start with the numerator. Now the numerator, remember when we're factoring, we always start by taking out a GCF if possible. So if you look at the numerator, we know that our GCF is 3. So we're going to start by pulling out a 3. Okay. And in the denominator, we're going to pull out a GCF of 12. So we have this. All right, we're going to keep going. We're going to continue to factor here. Okay. So I'm going to bring this down a level. 3. We're going to factor that numerator. Well, we know it's going to be 3x and x. And what two numbers multiply to be 1? It has to be 1 and 1. We just have to figure out our signs. If we want it to be a positive 2x in the middle, you have to have 3x times 1 be that positive. And then negative 1x. Positive 3x plus a negative 1x is the positive 2x, right? And in the denominator, we're going to factor that as well. X plus 1, x minus 1, difference of two perfect squares. And then we know that this simplifies to be 1. Okay? And 3 over 12 simplifies to be 1/4. So what are we left with? we're left with 3x minus 1 over 4 times x minus 1. And that is simplified. And I should have these in here as well. I apologize. Okay, so that's simplified. All right, so let's try another one. And it's going to be a ton of factoring. That's why we did all that practice, okay? All right, so numerator, 4x cubed plus 16x squared. Denominator, 2x cubed plus 6x squared minus 8x. You're always starting with pulling out a GCF. GCF in the numerator, 4x squared. Factor that out and we get x plus 4. Denominator, GCF, 2x, x squared plus 3x minus 4. Okay, well, it looks like in that denominator we can factor again. So we're going to keep our numerator. And we're going to factor this out. And we have x and x, plus and minus, 4 and 1. So what simplifies here? This simplifies. We get 4 over 2, which we know to be 2, and an x. So our final answer, 2x over x minus 1. Okay, so you're constantly factoring and looking for things to simplify. Next page. Let's try another one. Oops. 2 minus x over x squared plus x minus 6. So the numerator doesn't look like it's going to factor. Now, what I can do, because I don't normally like to see things written as 2 minus x, I like to see things written with the x first. What we can do is we can factor out a negative, which would make this x minus 2, just so it's easier for us to see. Okay. And then in the denominator, we would have x plus 3, x minus 2. That simplifies. And we get a negative 1 over x plus 3. Now you should remember this from last year. We did a lot of this last year. The only difference is the factoring may be a little bit more difficult this year. Okay, so in the last example, we saw that 2 minus x over x squared plus x minus 6 and negative 1 over x plus 3 are equivalent expressions. This means that they have the same value for all numbers that are in both domains. However, this does not mean that their domains are the same. Because if we look at the first one, there's going to be 2 values that make this undefined. And in the second one, we're going to have 1 value that makes it undefined. Now, we're going to get a little bit more into this further on in the year, but we start talking about discontinuity and holes and removable discontinuity. So that's where we're going to be going with this. Now, yes, they're equivalent expressions. Are they the same? No, absolutely not. All right, so multiplying and dividing rational expressions. That's our next piece. Okay, so to multiply, we simply multiply numerator by numerator, and then denominator by denominator. And we simplify where we can. Dividing, we have to do, remember, dividing fractions, we keep, change, flip. So keep, change, flip. Okay, so multiply, numerator, numerator, denominator, denominator, divide, keep, change, flip, factor, 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 cancel, cancel, cancel. Okay, so lots of factoring, lots of simplifying. We just have to remember our rules for fractions. Next page. Let's give one a shot. A squared minus 4 divided by 16a times 20a squared divided by a plus 2. So the first thing that we're going to do is we're going to factor as much as we possibly can. Numerator of the first fraction is very simple, difference of 2 perfect squares. and that's the only other thing factorable. Now we're going to simplify. And remember, when we're simplifying fractions, you can do it vertically up and down or diagonally, never horizontally. Okay? So I can simplify a plus 2 diagonally. I can simplify a and a squared. And then 16 and 20. 16, 4 goes into 16 4 times, and it goes into 20 5 times. Okay? So let's look at what I'm left with. I'm left within the numerator. Now don't forget that these pieces, they haven't gone away, they're still there. 5a times a minus 2, and in the denominator I'm left with just a 4. Okay? So you can simplify diagonally and vertically, never horizontally. Okay, so let's try the next one. X plus 4 divided by x squared minus 6x times x to the fourth minus 9x squared divided by x squared plus 2x minus 8. So again, we're going to start by factoring. X plus 4 stays. So notice I put it in parentheses just so it's easier to see. As you see up in the denominator, 2x. Numerator. X to the fourth, 9x squared. That's the difference of two perfect squares. X squared plus 3x, x squared minus 3x. And in the denominator, x, and it looks like positive 4, negative 2. So now we simplify. We have a little bit more we can do. I mean, we can start by crossing that out, but let's see if we can do anything else. All right, x squared plus 3x. I'm just going to rewrite it. X squared minus 3x, 2x, x minus 3, x minus 2. All right, look in the numerator. X squared plus 3x, x squared minus 3x. What do you notice about those? They have GCFs. First one has a GCF of x, and the second one has a GCF of x. So I could pull out an x and another x. Okay, now I'm going to have more to simplify. Okay, so there's an x, and there's an x minus 3. So my final answer, x plus 3. Don't lose that 2. And there's your simplified. Okay, so always continue to factor as much as you possibly can. Sometimes it won't be obvious, and you'll see it at the end, and you'll have to redo. Okay? All right, next page. Let's try division. Now remember, division is simply multiplication. We just have to do one step before. All right, we keep, change, flip. Okay, so now that we've done our keep, change, flip, that's always first with division. Now we can factor. Doesn't look like I'm going to factor anything here. I know that looks kind of crazy. Let's fix that. But it looks like I can factor out a 3x squared. And then the denominator, x minus, and 2 and 2. All right, so let's see what can be simplified. And x minus 2 gets simplified. And the 3 and the 12 becomes 1 and 4. It doesn't look like there's anything else to simplify. So our final answer is x squared times x plus 5 over 4 times x minus 2. Okay, so division is simply multiplication, just with an extra step thrown in there. Next page. All right, now, what does a fraction mean? Well, fraction just means division, okay? So that's all it is. So we have to keep change, right? This is division, gets changed to multiplication. Flip. This is what we're flipping. Now we can factor. Now, something should be jumping out at you. You have that y cubed minus 1, right? That's difference of cubes. You know how to do this. So if you have to take a minute, pull out that flashcard and find how you factor it, please. Okay. So y cubed minus 1 gets factored. Y minus 1. Y squared plus y plus 1. Okay. Y plus 1, y minus 1 in the denominator, difference of two perfect squares. And y plus 1, y plus 1. And y squared plus y plus 1 is not factorable. We'd really like it to be, but it's not, so we're just going to leave it. Okay, so now let's see what can be simplified. We've got a y plus 1. We've got a y minus 1. We've got a y squared plus y plus 1. We've got another one over there. So all we're left with is y plus 1. Okay. Moving on to the next page. Adding and subtracting rational expressions. All right, so very important. When you add and subtract fractions, you have got to have a common denominator. You do not need one for multiplying, dividing. You absolutely need one for adding and subtracting. So let's look at the first one. X squared minus 4x plus 4 divided by x squared minus 3x plus 1 plus x plus 4 divided by 2x minus 2. We have to have a common denominator. Now, obviously, you don't have one, so we have to work on getting one. So what we do in order to find a common denominator is we start by factoring what we're given. Okay, so we're going to start by factoring this 2x squared minus 3x plus 1. And you've had a bunch of practice with factoring now. 2x and x, signs are different, or the same, I'm sorry, and 1 and 1. That's a very easy one to factor. Over here, we know that, we know that we could pull out a GCF of 2, and we get 2 times x minus 1. So they do have a little something in common. They have that x minus 1 in common, right? So our LCD is going to be 1 of everything. We've got a 2, right? We've got an x minus 1 that's shared, and we have a 2x minus 1. So you have to have all 3 of them when you're getting your common denominator. Okay? So here's how we start. We have our 2, and I'm going to change it up, 2x minus 1 and x minus 1. The board is not playing nice. And we're going from here to here, right? What did I have to tack on to make it look like this? Well, we had to tack on a 2. So that means in the numerator, you're also going to have to tack on a 2. Okay? Now, same thing for the next piece. We want it to be 2 times 2x minus 1 times x minus 1. What did we have to tack on? We had to tack on a 2x minus 1. So x plus 4, 2x minus 1. Okay, so now we have a common denominator. Now what we're able to do is we're able to add, right? When we add, we keep our common denominator. But what we have to do is deal with this whole mess up in the numerator. We're going to have to distribute the first. And we're going to have to FOIL the second. I know I'm going long here, okay? So now I got that big mess up top, right? I want to combine those like terms. So I've got a 2x squared and a 2x squared, which we know gives us a 4x squared. We've got a negative 8x and a positive 8x, so those are going to simplify for me. Very nice. We have a negative x. We're going to throw that in there. And we have 8 minus 4, which is 4. And we still have this in our bottom. You always bring everything down, okay? And I apologize, but I'm going to have to come up here now. Okay, so now I have to work on factoring that numerator, 4x squared minus x plus 4. Okay, that's going to get factored, if I can. So, does it factor? Well, let's give something a shot. Gotta always try. Let's try 2x and 2x. And we want 4 on the end, so let's try 2 and 2, right? Signs are going to be the same. They're both going to be minus. 2x times 2x is 4x. Minus 4x. Minus 4x. Uh-oh, that's going to give us a negative 8x. That won't work. Okay, so let's try 4x and x and 2 and 2. Well, 4x squared minus 8x, minus 8x minus 2x. Nope, won't work. How about if I try 4 and 1? 4x minus 4x minus 4x. Uh-oh, negative 8x. Okay, so we've done all we can do. It is indeed not factorable. That is your final answer. Okay, so I know that these take quite a bit of time and quite a bit of practice. I am going to stop there because I am out of time. So you're going to watch the next video tomorrow night. And I will see you guys tomorrow. Bye.